Welcome to Digital Signal Processing Online Lecture Series. Myself, Reema Rawal from LG Institute of Engineering and Technology. Today's topic is linear convolution from the unit number 2, that is discrete time signals and system. In previous session, we have seen the first method of linear convolution, that is mathematical method. And in previous sessions, we have seen variants of the examples using mathematical method to find linear convolution. Okay. We have seen the linear convolution formula, then the methods of computing linear convolution, which were mathematical method, tabulation method and graphical method. In this session, we are going to study the second, that is tabulation method. So this method will give you a smart method as compared to mathematical method and graphical method to find linear convolution of any given data. Let's see how this method goes. For example, you are given to find the convolution of x of n and h of n, that is input signal and impulse response of the signal, and you need to find the y of n for that, right? So let us consider that x of n has three values, which is x of 0, x of 1 and x of 2, right? That means this will be any value given to you, and at the same time h of n, that is this, equals to h of 0, h of 1, h of 2. Again three values given to you, right? Now in tabulation formula or in tabulation method, all you need to do is you need to make a table like this, in which in this horizontal part there will be always x of n, and here there will be always values of h of n. That means here it will be x of 0, x of 1, x of 2, right? So here in horizontal part you will place x of n. Here it will be h of n, that means it will be h of 0, h of 1, h of 2, right? So in this vertically we are going to place values of h of n, right? Now in this we are going to multiply the respective values, that means first element value will be h of 0 into x of 0, that means this will be x of 0 into h of 0. Then next value, that means multiplication of x of 1 into h of 0. So here it will be x of 1 into h of 0, that means respective elements multiplication. Okay, so here it will be x of 2 into h of 0, right? So x of 2 into h of 0. Now in second row, multiplication of these values with this h of 1, that will give you x of 0 into h of 1, then x of 1 into h of 1, then x of 2 into h of 1, right? Likewise in the third row it will be x of 0 into h of 2, then x of 1 into h of 2 and x of 2 into h of 2. Okay, now we need to divide this as a segment like this. That means this kind of segments will be there to determine the output values. Okay, so this kind of segments or division will take you to the final values of the output convolution system function, right? So now here output function will be given as y of n, that is equals to first, that means x of 0 into h of 0. Second value will be the addition of these two values, that means it will be x of 0 into h of 1 plus x of 1 into h of 0, plus the next will be third element or third value will be addition of these three values, okay, plus the next value will be addition of these two values, and the last one will be addition of this, that means, or else you can say multiplication of this directly, right? So this will give you the y of n, that means First element will be x of 0 into h of 0, right? So first element is x of 0 into h of 0. Second value is addition of this 2. So this will give you second value. Then the third element value will be addition of this. That means it will give you y of n for the third value. Then the addition of this 2 will give you the fourth value. And the last value will be this. So this is the way you can obtain the 5 values of y of n. Okay, let us understand this with the example. Let's say, for example, consider the data which is x of n, that is equals to 1, 2, 1, 1, and h of n equals to 1, 1, 2, 1. Okay, here arrow is given at this first position. Alright, so now using the tabulation method, we need to make the table like this, in which horizontal values will be x of n and vertical values will be h of n, right? So here we will write 1, 2, 1, 1, and here it will be 1, 1, 2 and 1. Okay, so now multiplying this 2 will give 1. So 1 into 1, 1. Now next 1 into 2 is 2. 1 into 1 is 1. Then 1 into 1 is 1. Now next value 1 into 1, 1. This 1 into this 2 is 2. 1 into next one, that is 1, 1, right? Now third element with these x of n values. So 2 into 1, 2. 2 into 2, 4. 2 into 1, 2. 2 into 1, 2. Okay. Now next 1, 2, 1, 1. Okay. Now we are going to make the segments or divisions like this, vertical divisions, or as you can say partitions. It will be like this. Okay, so now what will be the output? So y of n, that is equals to first element, that means this is 1, then addition of this 2, that is 1 plus 2, that will give you 3, and the next value 2 plus 2, 4, plus 1, that is 5, then 1 plus 4, 5 plus 1, 6 plus 7, 6 plus 1, that means 7, then 2 plus 2, 4 plus 1, that is 5, then 1 plus 2, 3, and the last value is 1. So these are the values of output sequence, or else you can say convolution output for the tabulation method, right? Now we need to indicate the arrow. So as you can see in this, x of n is at this position and h of n initial position is this, right? So whenever you are making arrow in the output system function using tabulation method, you need to make the intersection of these two arrows. Where the intersection occurs, that will be the value where you need to point out the arrow in the answer, right? So here the intersection is at this position. So here the value 1 will indicate y of 0, right? So this is the answer of y of n using the tabulation method. Okay, let us consider another example. So next example, here let us consider x of n, that is equals to 2, 1, 2, 3, and h of n equals to 2, 1, 1, 2. Okay. Now in this case, let us consider the arrows at different positions so that we can obtain the output and we can indicate the arrow function. In this, we are going to put the values of x of n horizontally and h of n vertically. Okay, so x of n is 2, 1, 2, 3 and h of n is 2, 1, 1 and 2, right? So same method, we are going to multiply this entire row with respective values of h of n. So first this will give 2 into 2, 4, 2 into 1, 2, 2 into 2, 4, 2 into 3, 6. Okay. In next row, 1 into 2, 2, 1 into 1, 1, 1 into 2, 2, 1 into 3, 3. Okay. Then next, 1 into 2, 2, 1 into 1, 1, 1 into 2, 2, 1 into 3, 3. The next will be 2 2s are 4, 2 into 1, 2, 2 into 2, 4 and last 2 into 3 will give you 6. Okay, same way we are going to make the partitions and we are considering the segments to get the output system function. Okay. Alright, so here y of n equals to first one, that means first value, this is 4, then 2 plus 2, that is equals to 4, then in third segment 2 plus 1 3, 3 plus 4 7, next 4 plus 1 5, 5 plus 2 7, 7 plus 6 13. Okay. Then next 2 plus 2 4, 4 plus 3 7, then next 4 plus 3 7 and last value is 6. Okay. So these are values of y of n. Now we need to denote the arrow. So here x of n arrow, that is 0 position, is at 2. For h of n the arrow is at last 2. Now we need to find the intersection for this to denote the output origin function. So it will be at this, that means the arrow will be at 4 plus 3 value, that means this 7 value. Okay. So this is the output function or as output system function for the given data system. Alright. Now as you can see in both of these examples, that is this previous one and in this, we have considered the range of x of n and h of n same. That means both have the same values of x of n and h of n. That means values are different but the number of values are same. That means here x of n is 4 values, that means 1, 2, 3, 4 and h of n also has 4 values. Now we are going to consider another example with different length of sequences for x of n and h of n. The method will be the same and the concept will be the same. Okay. So now let us see next example for which x of n, that is equals to 1, 2, 3, 4 and h of n equals to 1, 0, 1. Okay. Here arrow is at the first position for both of them. Okay. So now according to the tabulation method, we'll make the table like this. The horizontal will denote x of n, this will denote h of n. Okay. So now let us place the values. X of n is 1, 2, 3, 4 and h of n is 1, 0, 1. Okay, and at x of n the arrow is at the first position or first value 1, and in h of n again the arrow is at the first position. Okay, now let us multiply this with the respective values. So 1 into 1, 1, 1 into 2, 2, 1 into 3, 3, 1 into 4, 4. Okay, then 0 into this entire values, that will give you 0. Okay, then 1 into this entire values, that will give you 1, 2, 3 and 4. Okay, now same way we are going to take the partitions, or we are going to make the segments. So it will be like this. Okay, now same way we are going to find the output function y of n. So here the first value is 1. Next value is 0 plus 2, that will give you 2. So the second value is 2. Then 1 plus 0 plus 3, that will give you 4. Then 2 plus 0 plus 4, that will give you the value 6. Then 3 plus 0, that will be equals to 3, and the last value in this segment is 4. So this is the answer of this sequence, right? And the arrow will be at this, that means at the first value. Alright, so the method will be the same irrespective of the length of the sequences given to you. You need to place the values of x of n horizontally like this, and you need to place h of n vertically like this. You need to cross multiply this, or else you can say multiply with the respective values and then make the segments, and in the particular segment you need to make the addition. Okay, so this is the answer of linear convolution for the given data using tabulation method. So as compared to mathematical method or graphical method, which is actually a lengthy method, this tabulation method is very short and you can find the answer in very less steps and accurately. Okay, so whenever in the exam the method is not mentioned, you can use any method, but this tabulation method will be short and less time consuming for you, and it will be easy for you. Okay, so I hope this is clear to you now. For any of the data given to you, these are the references. Thank you.